Hello student, in this class I will discuss how sensitivity is affected by feedback. Okay, so let's start our discussion. Sensitivity is a very important factor in control system. So here I am going to consider sensitivity as S. So if we define sensitivity, then we define this sensitivity in this manner. Let the variable in a control system which changes its value be capital T, such as output, and this change is considered due to parameter variation of element. Element means capital G, such as gain, or it can be gain or it can be feedback path gain. Okay, then the control system sensitivity is expressed as percentage change in capital T divided by percentage change in capital G. So here we write the sensitivity in terms of T and G, where T is the overall transfer function and G is the forward path gain. And we express this sensitivity function by this notation as TG, and this notation denotes sensitivity of variable capital T with respect to parameter capital G, and this notation can be defined by dou T by T divided by dou G by G, where dou T is the incremental change in capital T due to incremental change in capital G. So this ST by G is equivalent to dou T by dou G into capital G by T, because the sensitivity here, the sensitivity of variable T with here the sensitivity is the variable of T with respect to parameter G. Now if we consider a open loop system, then we know the transfer function of open loop system is Ts equal to Cs by Rs. Cs is the output, Rs is the input, and this is equivalent to Gs. So if we put this T value in this sensitivity equation, then the open loop sensitivity is 1. Okay. Now come to the closed loop system. This is our closed loop system, and we consider here negative feedback. So the transfer function of this closed loop system is Ts equal to Cs by Rs. This is equivalent to Gs divided by 1 plus Gs Hs. Okay, now from this transfer function we will find the sensitivity. So what we do? First we will find this dou T by dou G. Okay, so if we consider closed loop system, so the closed loop system transfer function T equal to G by 1 plus GH. Okay, so if we differentiation this transfer function with respect to Gs, then we find dou T by dou G equal to 1 by 1 plus GH whole square. Okay. Now put this dou t by dou g in the sensitivity equation, okay, and put the t value, put the t value in this t, okay. So if we simplify this equation after putting dou t by dou g and transfer function value in the sensitivity equation, we find the closed loop system sensitivity, then find the sensitivity of the closed loop system is 1 by 1 plus gh. Okay, clear? So here again we have seen the sensitivity of the closed loop system also depend on the 1 plus gh factor, okay. So if you are increasing your feedback path value, then sensitivity is going to reduce, same as gain. If we are here, if you are decreasing this value, means if gh is negative, so if gh is negative, then this value is decreased, then that time our sensitivity is going to increase. If gh value is positive, then denominator is going to increase, therefore the total value of sensitivity is going to decrease. So here the sensitivity, so here the sensitivity value is also depend on this 1 plus gh factor. If this gh is increasing, sensitivity is going to decreasing. If this gh is decreasing, sensitivity is going to increasing, okay. Now if we compare the open loop sensitivity and closed loop sensitivity, open loop sensitivity is 1 and closed loop sensitivity is, what is closed loop sensitivity? Closed loop sensitivity is 1 by 1 plus gh. So if we consider this open loop sensitivity and closed loop sensitivity, it is observed that the sensitivity of the overall transfer function with respect to forward path transfer function, forward path transfer function means GS, because GS is the forward path gain. So if we compare this open loop sensitivity and closed loop sensitivity, it is observed that the sensitivity of the overall transfer function with respect to forward path transfer function in the case of closed loop control system is reduced by a factor 1 plus GH, okay, as compared to open loop system. Means in closed loop system, sensitivity is reduced by a factor 1 plus GHHS, okay. So we can conclude here that the sensitivity of the overall transfer function, if we compare open loop and closed loop system, then the sensitivity of the overall transfer function with respect to forward path transfer function in the case of closed loop control system is reduced by a factor 1 plus GHHS as compared to open loop system. And it is preferable that the sensitivity function should be minimum in control system. In control system application, it is preferable your sensitivity should be minimum, okay. Now come to the next slide. Now here we have seen how sensitivity, in this slide we have seen how sensitivity of overall transfer function, here we consider the overall transfer function Ms instead of Ts. So in this slide we have seen how sensitivity of overall transfer function Ms with respect to feedback path transfer function. Okay. So the sensitivity function, sensitivity function for the overall transfer function Ms with respect to variation in the feedback path transfer function Hs is written as mh equal to dou ms by ms divided by dou hs by hs. So we know the overall transfer function, that means ms, for closed loop control system, if we consider the negative feedback, then the transfer function ms is equal to gs by 1 plus gshs. Now we differentiate this ms with respect to hs. So after differentiating ms with respect to hs, we get gss square, we get this equation gss square divided by 1 plus ghs whole square. So now putting this differentiation value or ms value in the sensitivity equation. So after putting this value in the sensitivity equation, we get the sensitivity of the overall transfer function ms with respect to feedback path transfer function is equivalent to minus gshs divided by 1 plus ghs. So if we comparing the sensitivity function of overall transfer function with respect to forward path transfer function gs of a closed loop system, if we compare the sensitivity of overall transfer function with respect to forward path transfer function gs and the sensitivity of overall transfer function with respect to feedback path transfer function, it is concluded that a closed loop control system is more sensitive to variation in feedback path parameters than the variation in forward path parameters. Therefore, the specification of feedback elements in a closed loop control system should be more rigid as compared to that of forward path elements. Okay. Now coming to stability. How stability is affected by feedback. So when we can say the system is more stable whenever output is more controllable, whenever our output is in our control, then say that the system is stable system. So here, for example, if you are having control system and the transfer function of this control system like gs divided by 1 plus gs, and if your gs value is equivalent to negative, okay, that means you have a control system and you have a negative feedback control system and the transfer function of this control system is gs by 1 plus gs. Now if your gh value is equivalent to negative, then what will happen? What will happen? What you will get? You are going to get g by 0. Okay, if your gh value is negative, then the transfer function is equivalent to g by 0. So this is equivalent to infinite. So your overall gain or output or anything is not going to be in your control. You are going to get infinite value in your transfer function. Okay. If your transfer function is equivalent to infinite, transfer function means output by input. Here output is CS and input is RS. So if your transfer function is infinite, that means CS by RS equal to infinite. So that it implies your output is equivalent to infinite when you are not having the control of the system. So you consider the system is unstable. So your stability is also controlled by the feedback, because your feedback, that means GH is negative. If your transfer function is G by 1 plus GH and your GH value is negative, then your transfer function or output or anything is infinite. Okay. So when your transfer function is infinite, that means your output is equivalent to infinite when you are not having the control of the system. So you consider the system is unstable. So your stability is also controlled by the feedback. If your GH is equivalent to -1, you are losing your control. So that's why you need to take care of your feedback to control the stability. So that it means your feedback is having effect on stability also. So that's why you need to take care of stability. You need to take care of feedback to get the better stability of the system. So by this class, we come to know that the overall gain of the system is going to affect by the feedback of the system, because in previous class we have seen gain also depend on the feedback. So the overall gain of the system is going to affect by the feedback of the system, and generally the gain of the system is G. For open loop system, the gain is G. But whenever you have the closed loop system, then the overall gain is G by 1 plus GH for negative feedback. So overall gain of the system is going to affect by the feedback. If the feedback increase, the overall gain will be decrease. Like that sensitivity, we saw that we got sensitivity is 1 by 1 plus GH in closed loop system. So here also the sensitivity is going to affect by the feedback path. If this 1 plus GH is high or low, then your sensitivity is going to affect. Similarly, stability. Your system is stable when your output is controlled. So output is controlled by the feedback now. So whenever you choosing better feedback path, then only your system is having control on output. Whenever you are having control on output, then you can say that is a more stable system. So all these factor means gain, sensitivity, stability are going to affect by the feedback of the system. Thank you, student.